At this point in our model, I think it is finally time for us to turn our attention to the building's systems. So we've done an awful lot of modeling so far when it comes to the geometry and the material parameters of the building, but now I think we can turn our attention to things like the fresh air ventilation system and the domestic hot water system in particular. Eventually, we'll turn our attention to heating and cooling systems and talk about configuring the PHPP in order to complete our exercise here. But the first step is to add a dedicated fresh air ventilation system to our passive house here. Of course, that's going to be really important for PHI certification. It's going to be really critical that we accurately model both the actual system components themselves, the HRV, the ERV, the ducting, what have you, and to configure the fresh air ventilation and flow rates for each of the individual spaces inside of our building. So we've already started to touch on that when we were looking at spaces, but we'll turn our attention to that in quite a bit more depth, and we'll also look in depth at the ERV and system component tools that we have available inside of our PHTools toolbox here. So if you've been following along, you should hopefully have something that looks roughly like what I've got here, with a simple single-family home with a couple of thermal zones, modeled in Rhino with a bunch of parameters associated and then flowing through into our Grasshopper definition, where it gets built as a honeybee model and then exported out to the PHPP. So in our last series of videos, we built up the geometry of the building and we started to build out the interior spaces, the PHPP spaces, the individual elements, and assign some data there. And as I said, in our next step here, we want to start to add a fresh air ventilation system. So how are we going to do that? Well, as with most things here, of course, there are at least a couple of different ways that we can enter a lot of this information. I'm going to show you one method here, but of course everything is quite flexible and able to sort of take advantage of different workflows depending on the types of projects you're working on and what you how you want to work with the model. In any event, so let me come into my Grasshopper definition. Let me expand my Grasshopper definition here so we have a little more room to work with. And as I said, if you've been following along, hopefully your system looks something, or your setup looks something like this, where we are creating all of our honeybee zones or rooms. We are starting to configure the actual model itself, and then we export everything out to PHPP at the end. So if you remember, our honeybee zone or honeybee room creation started with the geometry of the room itself. We added some windows. That flows through into the honeybee room. And then the last step was we started to build out those PHPP spaces. We've got a multi-zone model here, so we do everything, we tidy up, we do everything a couple times, once for each zone, or excuse me, once for each honeybee room, to get used to the new vocabulary, once for each honeybee room. And then those rooms get combined in the honeybee solve adjacency tool that allows us to sort of figure out the interface surfaces between the rooms. Once that's completed, you can see the output of the solve adjacency tool are a couple of honeybee rooms, the first floor and second floor. Those then flow off to the honeybee model. So okay, our goal here is to model a fresh air ventilation system and apply it to both honeybee rooms. So the easiest place to do that is going to be after this solve adjacency is completed. So after the solve adjacency, we're going to make some room and we're going to add a new section to our Grasshopper definition here. And this new section is going to be for our fresh air ventilation. So let me set up the section here before we go too much further. We'll call this fresh air vent. So we've got some room in our Grasshopper canvas here. What do we need to add to our Grasshopper definition in order to create a fresh air ventilation system? Well, it's quite straightforward. If we come to our PHTools ribbon and we come over to O1 model, you'll notice that in O1 model, we have a whole section here in the middle dedicated to PHPP ventilation items. So we've got a PHPP exhaust ventilator, we've got a PHPP ventilation duct, a PHPP ventilation system, and a PHPP ventilation unit. And we'll sort of look at each of those in turn. So first of all, the way this is going to work is we're going to set up and configure a new PHPP vent system, and that vent system is going to get applied to one or more honeybee room in our model. Of course, there are lots of times where you're going to have different ventilation systems applied to different rooms in the model, honeybee rooms in the model. Maybe I have one honeybee room for the commercial podium and then a whole bunch of other honeybee rooms for individual, dwelling units in some apartment building above. And I might have totally separate ventilation systems for those different rooms. And so in the configuration here, you can build as many vent systems as you want, and then they get applied to different honeybee rooms as appropriate. So in our case here, we're just going to build one. We only need one single system to apply to both honeybee rooms. But of course, we could build multiple systems if for some reason we had a second floor ERV and a first floor ERV or something like that. So in any event, to get started, I'm going to come in here to my PHTools, to O1 model, and I'm going to come down to create new PHPP vent system, and I'm going to drop that onto the canvas. And let's take a look at what we have here. So this is how we create a new ventilation system. And notice we have some inputs. The ventilation system type, either balanced ventilation with heat recovery, an extract air only, or a window ventilation unit. We have the ventilation system name, the ventilation unit, so a bunch of information about the ERV or HRV itself. We'll take a look at that in some depth. A couple of inputs for ducts. So we've got a couple of different HRV ducts. These correspond to the two ducts which connect the ERV or HRV to the building envelope. So one of them being the air flowing in, and the other one being the air flowing out. And you'll have always with a ERV or HRV system, you'll always have two of those ducts, one for air coming in, one for air going out. So you've got two inputs for ducts there, and then a last input for the exhaust vent units. This is an optional input for things like kitchen hood exhaust or dryer vent exhaust, things like that, if you want to build those into your vent system, you have the opportunity there. And then lastly, of course, you have this honeybee rooms. All of this information is going to get applied to, added to, hosted by one or more honeybee room. So to get this started, and so also before we go, notice that if I just take a look at the standard output here, notice that I actually have a default ventilation system already built with some ducts and a default HRV, and some default configuration. So I don't have to set anything up here, and I get a default HRV or ERV system out of the box. Now, if I'm trying to model an extract air unit or some sort of window ventilation system, this wouldn't be appropriate. But out of the box here, we get a standard cold climate mechanical ventilation system, and so we can apply this to our honeybee rooms simply by taking the output from our solve adjacency, so my list of honeybee rooms, and inputting that into the honeybee rooms. So this vent system has now been applied to those input honeybee rooms. Notice the other output or the main output of this component are honeybee rooms, but they have been modified. We've added a bunch of new information to these honeybee rooms. In order for that data to flow, all we need to do is take the output here and pass it along to the next link in the chain. Now those modified honeybee rooms with their fresh air ventilation system are now flowing along out to our PHPP. And that's all we need to do in order to create a standard fresh air ventilation system. So maybe I made this a little too big. Maybe we'll make this a little smaller here. Pull these over a little bit, keep things from sprawling too far out of control. So we've got our fresh air ventilation system. We don't even need to do any setup. We have our default system. Of course, we'll come back and take a look at those various options. But let's see what this did for us right out of the box. So I'm going to come over to my export to PHPP. And I'm going to run my export to PHPP, and let's see what our PHPP looks like once that is done exporting. All right, so that's all exported out, and let's take a look. Let's take a look at our PHPP. So here's our PHPP. We're pretty familiar with all of this by now. All of our surfaces. We have all of our windows streaming through with all of their information. But the new piece that we want to take a look at, let me make this a little bigger. The new piece that I would like to take a look at has to do with the ventilation system. So if I was to come in here to the ventilation worksheet and click on the ventilation worksheet, notice that the ventilation has been set to balanced passive house ventilation with heat recovery. And if I come down here a little further, notice that when I use the LadybugTools model and to connect it to the PHPP, by default, it's going to set up the multiple ventilation units worksheet. Now, you might not be familiar with this worksheet. If you've only ever done small single-family home projects in PHPP, maybe you're familiar with this piece of the ventilation worksheet. But for most projects, and certainly any project that has more than one ventilator, you're going to use what's called the additional ventilation worksheet instead of this simplified calculator. So the way that the LadybugTools export works by default is that it's going to make use of that multiple ventilation units additional ventilation worksheet, even if there's only a single ventilator. So let's take a look at that additional ventilation worksheet instead. So all the work is getting done over here in the additional ventilation worksheet. And what do we see here? So we see a bunch of reporting information at the top. We see some flow rate information over here. Results for the overall vent system, 0.38 air changes per hour. So that's not too bad. That's pretty good. We might actually boost that up a little bit. Usually we would shoot for like 0.4 to 0.5. 0.38 might be a hair low, but not bad. And we see some flow rate information. And then if we scroll down, we see a whole bunch of really detailed information. So what are we looking at here? What is all this? Well, here we see all of our various spaces. Here we see the ventilation unit, which is allocated to that space. We see the area of the space. We see the ceiling height of the space. And then we see a whole bunch of flow rate information and a bunch of schedule information over here. What this is saying is that in the closet, there's going to be 3 cubic meters per hour of fresh air supply, 3 cubic meters per hour of fresh air extract. It runs 24 hours a day, 7 days a week with 0 days off for holidays. And it runs at that peak flow rate 24% of the time. Well, it runs at 98% of that flow rate 24% of the time. And it runs at 85% of that flow rate 3% of the time, and then it runs at 72% of that flow rate the remaining 73% of the year. Oof, that's awfully specific and weird, and I don't know where all this came from. Well, I do, and we'll talk about it. But we didn't enter any of this information, right? So where did all this come from? We'll talk about that. So in any event, we have our detailed room-by-room breakdown. Notice these are all of our rooms that we entered in the TFA entry section and all of the associated information there. Now, if we scroll down a little further, so this is our detailed room-by-room breakdown. Now, if we scroll down a little further, we have some information here about the actual ventilation unit. So there's our default HRV unit. And we give it a little name, and notice it's just got some stand-in values for right now, 75% heat recovery. So because we haven't given any explicit information here, this is what is going to get entered by default. And then lastly, down at the bottom, we have a little bit of information about the ducting. So as I said, any HRV is going to have some ducts. So here's one set of duct. Here's the second set of duct. You can see they're 4-inch diameter with some fiberglass insulation, 2 inches of fiberglass insulation, and 5 meters in length each. So again, by default, these are the values that you get. So not that great, 75% efficient, 5 meters of ducting with only 2 inches of insulation. and then some kind of bizarro schedule stuff here, and I have no idea where, well, I do know, but we didn't enter these flow rates. So where did all this flow rate stuff come from and schedule stuff come from, etc., etc.? Well, when we come back in the next video, we will take a look at that. But just to reiterate here, so by adding just this single component, so a single component here went off and did all that work, and it sort of configured everything in our PHPP. But of course, we can come in, and we will come in, and we will modify and customize a lot, or if not all, of this information. So by default, it's going to work right out of the box. But of course, we want to gain control over this, and we want to be able to customize this and set this up exactly the way we want. So when we come back in the next section, we'll turn our attention to some of the component pieces. We'll take a look at the ventilation unit itself. We'll take a look at some of the ducting. Maybe we'll add an extract vent unit, that kind of stuff. And then in the subsequent video, we will turn our attention to the question of the flow rates and the schedules that the flow rates are operating on. So I'll see you back in the next video, and we will continue on with our fresh air ventilation system modeling.